Welcome to this explainer. Today, we're looking at network architecture, but through a pretty fascinating lens, building and defending a digital fortress. It's wild to think about, right? Every single time we connect a device, we are literally building an invisible infrastructure that immediately needs to be protected from just a constant barrage of outside threats. So in this explainer, we're going to explore exactly how this infrastructure actually works, how malicious actors try to break in, and the highly specific tools security pros use to keep our data completely safe.
Okay, let's dive into this and lay out our roadmap. We are basically going to build our network, attack it, and then secure it, step by step. We'll start with the anatomy of a network, move into data packets and protocols, look at common network attacks, outline essential security tools, and finish up with security hardening practices.
Section 1, Anatomy of a network, the building blocks. Let's look at the physical foundations of our fortress.
At its most basic level, a network is simply a group of connected devices sharing data. But the scale of that connection totally changes the game. On one side, we have a LAN, or local area network. This is your small footprint. Think of your home Wi-Fi or an internal office building. On the flip side is a WAN, a wide area network, which spans massive, widespread geographical areas. In fact, the internet itself is essentially just one gigantic WAN. And bringing these networks to life requires specific physical devices. We use modems to pull the internet into our LAN, routers to connect different networks together, and hubs or intelligent switches to route the data between specific devices inside that local network.
Section 2, Data Packets and Protocols, the rules of the road. Now let's see how data actually travels across these building blocks.
So whenever you send a message, download a file, or stream a video, that data isn't sent as one giant heavy chunk. It's actually broken down into much smaller, basic units of information called data packets. Literally all communication over a network happens when these individual little packets are transferred from point A to point B.
And this brilliantly illustrates how it works. Think of a data packet exactly like a piece of physical mail. The header is your envelope. It contains the IP address and the physical MAC address of both the sender and the destination. The body is the actual letter inside, the actual message or data you're trying to send. And finally, the footer acts like a signature, telling the receiving device, hey, this packet is complete. When this digital envelope hits a network switch, the switch looks up the MAC address in its internal table, which is basically just like a post office using an address book, and routes it perfectly to the correct device.
But before these packets can even be exchanged, devices have to strictly agree to communicate. Let's say you're visiting a website like Yummy Recipes for Me. Your computer doesn't just instantly grab the data. Instead, it performs a three-part TCP handshake. First, your device sends a synchronize or SYN request. The server replies with a SYN/ACK to acknowledge it. Then your device sends a final ACK to officially establish the connection. In the absolute blink of an eye, protocols like TCP for the handshake, ARP to find the next router's MAC address, HTTPS for secure encryption, and DNS to translate that website name into an IP address are instantly working together in the background.
To actually make sense of all this invisible traffic, security professionals use a standard framework called the TCP/IP model. It's broken into 4 layers to help visualize the activity. Up top, the application layer is where your user interactions, like email, happen. Pushing down, the transport layer steps in to control traffic flow and correct errors. Below that, the internet layer handles routing the IP addresses. And right at the base, network access deals with the physical, hardware transmission of those data packets across your cables and switches.
Okay, so we've successfully built a highly functional network where data packets zoom around flawlessly based on strict rules. But here is the critical tension point. What happens when this data falls into the wrong hands?
Section 3, Common Network Attacks, the enemies at the gates. Let's look at the specific tactics attackers use to breach the fortress.
One massive threat is packet sniffing, which loves to happen on unprotected public Wi-Fi, like when you're working at a local coffee shop. Attackers just hang out on these networks using software to spy on your data packets. In passive packet sniffing, they simply read your unencrypted data in transit. It's like a malicious postal worker quietly reading your mail. Actually, active packet sniffing is way worse. They intercept and alter the data while it's moving. They are literally changing the letter inside the envelope before it arrives. Attackers also use a sneaky trick called IP spoofing, where they change the source IP of a packet to impersonate an authorized system and slide right past network defenses. But attackers don't always want to steal your data. Sometimes they just want to burn the entire fortress to the ground. They do this through denial of service, or DOS attacks, which are designed to crash a network by flooding it with garbage traffic. A SYN flood abuses that three-part handshake we talked about by overwhelming server ports with a rapid-fire wave of fake synchronized requests. An ICMP flood chokes network bandwidth by forcing the server to constantly send out error replies. And then, there's the incredibly dramatic ping of death, which crashes the system with one maliciously oversized packet.
To really picture the ping of death, think of a network server as an anthill. Each ant and confidently carry a normal-sized load of data. A normal packet? Totally fine. But a ping of death sends an oversized 64-kilobyte ICMP packet. Think of this like dropping a large rock on a small anthill. The network operations are instantly crushed under the weight and completely unable to function.
Section 4. Essential Security Tools. Building the defenses. Time to deploy the tools to block these attacks.
The primary gatekeeper of any network is the firewall. Now, what's really interesting about this slide is how much they've evolved. Older, stateless firewalls just acted on rigid rules. If a packet met the rule, it got in. If not, blocked. No memory, no context. But stateful firewalls, they are vastly smarter. They remember connection states and proactively analyze behavior. Taking it even further, next-generation firewalls combine stateful inspection with deep packet inspection, actively pulling cloud threat intelligence to adapt to new cyber threats on the fly.
And hey, remember that unprotected coffee shop Wi-Fi? A virtual private network, or VPN, is absolutely your best defense there. A VPN changes your public IP address and creates a secure, encrypted tunnel between you and the server. It does this through an incredibly clever trick called encapsulation. It literally wraps your sensitive data packets inside other data packets. That way, the routers can read the outside directions to deliver it without ever seeing your private payload inside.
Inside the actual fortress, organizations use network segmentation to create very specific security zones. First, the uncontrolled zone. That's the wild, untrusted internet. Then you have the DMZ, the demilitarized zone, which safely houses public-facing servers. Behind another thick firewall sits the internal network for regular private data. And at the very core is the restricted zone for highly confidential stuff. By compartmentalizing like this, if an attacker somehow breaches the DMZ, they're completely trapped and can't spread into the inner fortress.
We also use proxy servers. Think of them as dedicated middlemen verifying safe connections. A forward proxy hides the user's IP and approves their outgoing requests to the web. On the flip side, a reverse proxy takes external traffic and safely hands it off to internal servers, so those internal machines are never ever directly exposed to the internet. And an email proxy is a lifesaver. It verifies senders and actually blocks up to 95% of spam and phishing attacks before they even reach an employee's inbox.
Section 5. Security Hardening Practices. Ongoing Maintenance. This is the final phase. Constant vigilance. Security hardening is the continuous process of strengthening a system to reduce its vulnerability and shrink its attack surface. If our network is a physical house, the attack surface is every single door and window a burglar could potentially try to pry open. Hardening is the ongoing, disciplined process of making sure absolutely every one of those entry points is securely locked, heavily reinforced, and monitored.
So the crucial point is that routine maintenance on your operating systems is a non-negotiable must. You have to install software patch updates the literal second they drop to close vulnerabilities. You need to establish a baseline configuration image so you instantly notice if a setting gets tampered with. It means properly tossing out old hardware and deleting unused software to kill unnecessary risk, and of course, strict password policies backed up by multi-factor authentication, or MFA.
And this hardening extends across the network and up into the cloud too. We perform port filtering to lock down unused communication ports. We enforce strict baseline images for our cloud servers. And crucially, we continuously conduct log analysis using a SIM tool, a security information and event management system. A SIM is an incredible piece of tech. It acts as a single pane of glass, the ultimate command center dashboard that pulls security data from everywhere, letting analysts prioritize and crush real-time security events instantly. Let's move to our roadmap and see how this builds a complete life cycle. We built the anatomy of our network, established the strict protocols, analyzed the brutal attacks, deployed our essential tools, and consistently hardened our defenses. We really cover an incredible amount of digital ground every single day. Just think about it. Right now, at this exact second, thousands of invisible data packets are leaving your device, navigating complex protocols and bouncing across the globe. So, armed with everything we've covered today, I want to leave you with one final thought. Look at your own network, your coffee shop Wi-Fi habits, and your passwords. Is your personal digital fortress truly secure? Keep learning, keep patching, and stay safe out there.